Okay, we're going to try a little new piece of technology here. If this looks different to you, it's because I'm using the Microsoft Whiteboard app. But let's get right into it, and we're going to talk a little bit about slope fields here today. And the first question is, what is a slope field? And I know the first time that I saw a slope field, it seemed a little bit strange. And real simply, a slope field is a graph of the possible solutions of a differential equation. As a matter of fact, the AP question I gave you on Friday had a slope field part to it. Okay, so when we talk about a slope field, I want to start by considering this differential equation dy dx equals 2x. All right. So if we separate our variables, multiply both sides by dx like we've been doing, I have that dy equals 2x dx. And if I integrate both sides, like we've been doing, integrate dy and integrate 2x dx, I get that y equals 2x squared over 2, which we know is just x squared, plus c. Now, we've talked about this constant, and we've learned how to find the constant if I'm given an initial condition. But what I want you to think about is that this constant could be anything. And if you think about the different quadratic functions we've worked with, you know, this could be y equals x squared plus 2. It could be y equals x squared minus 2. It could be y equals x squared plus 3, and the possibilities are endless. So if we think about what that could look like graphically, I could put on the granddaddy quadratic, where I just have y equals x squared. But what if I started putting in all the others? What if I put in x squared plus 1? And what if I put in x squared plus 2? And what if I put in x squared plus 3? And how about x squared minus 1? And maybe x squared minus 2? And now you're seeing a kind of like a buffet of all of the possible parabolas based on these different c values. Okay, we know that this c could be a whole bunch of different things: positive 2, negative 2, positive 3. It could be 0, and it could be a whole bunch of things. What I've just drawn here is kind of a sampling of what a slope field looks like. Now, we don't normally have all these little dashes, though. What happens in a slope field is they give you a grid that has, I can do a little better job drawing that line. They give you, if we just think of a normal coordinate grid, but then they put these dots in here, and you may have seen them the other day. And the dots typically are 1 unit. All right, so here's my dots this dot that I just drew was down at the x, this would be x is positive 1, the y is negative 1, and they put all these dots in all over the place, all right, like this. And you know, I could draw a whole bunch of these. Typically they don't make it much bigger than what I have here, and they also put them on the axis like this. All right, so what they're going to do is they're going to give you a differential equation. Well, let's use the one that we just had, dy dx equals 2x, because I showed you what a sample slope field could look like. So what we do now, and I'm going to get a different color, is we go to one of these points. Let's work with this one right here. All right, and let's think of what the coordinates are right here. The coordinates of this point are 1, 1. Okay, so what we do is we put in, this is an x, this is a y. I put in this value into the differential equation. Now I only have an x in this case, so that's the only one that I put in. If I would have had an x and a y, then I would have put them both in. So dy dx is 2 times 1, which equals 2. Well, remember what dy dx is. It's a slope. So we're saying that right here at this coordinate, the slope of the tangent line would be 2. Okay, so what we do with a slope field is we draw a very small little slashed line that looks like it has a slope of 2. Now you know what a slope of 1 looks like. We just make it a little bit steeper than that, all right? So that we'll call that a slope of 2, all right? So then let's come up to, I'll change back to blue, okay? Let's come up to this point right here. What are the coordinates of this point? Well, the x coordinate is 1, the y coordinate is 2. So when I plug it into dy dx equals 2x, I'm still plugging in an x coordinate of 1. 2 times 1 is 2. My little miniature tangent line right here is, we're going to draw one that has the same slope as the one below it. Okay, and guess what? If I plugged in this one, the x coordinate is 1, so it's going to be the same. It's also, and guess what? If I plugged in this one, it's also going to be the same. It's going to have a slope of 2. All right, now let's go here into the middle. What's the x coordinate right here? The x coordinate is 0. So if I plug in dy dx, if I plug in a 0 for x, I get 0. And that's the slope of the tangent line there. So I would draw a tangent line at the slope of 0. And guess what? All of these are going to be like that, because they're all going to have an x coordinate of 0. Okay? Let's go over to one of these negative x values, like this one. The x coordinate here is negative 1. The y coordinate, which doesn't matter on this particular differential equation, is positive 1. Let's plug in a negative 1 now. Dy dx equals 2 times negative 1. That's negative 2. And that's my slope over here. So now I draw in a tangent line that has a slope of negative 2. Try to make it match the other side, but make it a negative. And guess what? It's going to be the same thing right here. And it's going to be the same thing there. And it's going to be the same thing there. And if I go over here, to these ones that have, all of these ones that have an x-coordinate of 2, and I plug those in to dy dx equals 2x. If the x-coordinate is 2, 2 times 2 is 4, then these slopes of the tangent line are going to be even steeper. They're going to have a slope of 4, which I'm trying to draw here. This new app. And over here, they'd have a slope of -4 because all of these x-coordinates are -2. So if I plug in 2 times -2 over here, all of these are going to have a slope of -4. Every single one of them. And what you are seeing is the slope field for dy dx equals 2x. And if you look carefully, if we were to connect these, you can see that they would eventually take the shape of a whole bunch of little parabolas. Okay? And you can see that they are generally taking the shape of our U-shaped parabola. Steeper over here, not as steep here, flat in the middle. And this is an excellent example of a slope field. Now, some slope fields have both an x and a y in them, like, let me go back to my black pen, dy dx equals -x over y. So if I have a slope field here, now that we've got the idea, I can maybe move a little bit faster. And I've got my dots for my slope field. All right. Okay, and there's a good start to a blank slope field. We do the same thing. I plug in the coordinates of these dots. So what is the coordinates of this dot right here? It's 1, 1. Okay? So if I take this differential equation, dy dx equals -x over y, and I plug in a 1 for x and a 1 for y, then I get -1 over 1. So my little tangent line would be one that has a slope of -1 right there. Okay. How about if I come up here to the one right above it, and this is where you'll see the change. The coordinates of this point are 1, 2. Okay. So if I plug that in to this same differential equation, I put 1 in for x. I have -1 there, but the y coordinate is 2. Now my slope is -1/2, so it's not quite as steep up here as it was down here. All right. How about the coordinates of this point? Well, this is 1, 0. So if I plug that in, dy dx equals -1 over 0, we know that that is undefined, and there's only one kind of line that has an undefined slope, and that's a vertical line. Okay, so that would happen there. It would happen anytime that the y coordinate is 0. So all of these would be like that. Okay. Now, how about right here when the x coordinate is 0 and the y coordinate is 1? dy dx equals 0 over 1, which is 0. So right here, the slope of the tangent line is 0. It would be the same thing up here. It would be the same thing down there. Let's do one more. let's try this one here. The y-coordinate is -1. I'm sorry, the x-coordinate is -1. The y-coordinate is +1. If I plug that in to dy dx, I have the opposite of -1 over 1, which is +1. So here the slope of the tangent line is going to be +1. Up here it's going to be +1/2. If I plugged in, remember the coordinates of this point are -1, 2. If I put a -1 here and a 2 down here, it's going to be +1/2. And if we go all the way around here, you're going to find that, let's go over one more. What if this is -2, 1. So if I put in the negative of -2 over 1, I get +2, and it gets just a little bit steeper over here. This one over here would get just a little bit steeper. And what you're going to find out on this one is that this differential equation is showing, the slope field is showing the situation where this is all the possible circles. If I were to solve this differential equation the way that I've showed you by separating the variables, I would wind up with a circle with x squared plus y squared equals whatever that c is. And as you know, that is a circle. So this thing shows all of the possible circles. This is what a slope field looks like. Now, there's one last thing that I want to show you, and that is on your assignment that you're going to have tonight. And that's with multiple choice question, where they say match the slope fields with their differential equations. Well, what you want to do is you want to think about solutions here. If I have dy dx equals the sine of x, and I believe that I can copy and paste that image in there, if you give me just a second. There we go. So if you look at this problem, match the slope fields with their differential equations. Well, if you think about the antiderivative of sine of x, okay, I think we all know that the antiderivative of sine of x is cosine. Well, which one of these four graphs looks the most like a cosine curve? It's this one. All right. And look at this one. dy dx equals x. If we integrate both sides, we're going to wind up with an x squared. So which one of these four graphs looks like a whole bunch of parabolas? It's this one. So that means I got to work with these other two to match them up to these. And probably my best tip is to solve the differential equation and then match up the graph. My guess is that you're going to wind up with one of them having a horizontal asymptote. Look at this. There's a horizontal asymptote there. And on this one, it looks like there's a couple different possibilities. It could be a slant asymptote, or it could be a rational function, one of those rational functions where you've got kind of this and this business going on. So I just wanted to give you a heads up. You're going to get some practice with slope fields tonight, and that should get us a good start. We'll stop there.